Hello there and welcome. Today we're going to be building up a high-performance C4 transmission. This is going to be going into a full custom tube chassis dual-purpose on-off-road vehicle, and it's going to be equipped with a Ford 7.3 Godzilla engine. So basically we are replacing roughly 85 to 90% of the hard parts inside this transmission with highly modified and or rollarized, hardened and or billet counterparts. So I'll be honest, I've never built a C4 quite like this before. I don't do a lot of these transmissions. So I decided to partner with Dynamic Racing Transmissions. So Matt and JR over at Dynamic, they have been incredible partners throughout this process and provided an overwhelming majority of the parts that you're going to see. Matt in particular, not only being a great point of contact for parts and advice and counsel, he also was able to get me parts out very quickly when I realized I needed either a different part or a part that needed to be modified to work with, some of the other components that Dynamic provided. So again, I want to give a huge shout out to Dynamic Racing Transmissions for all of their help and support throughout this entire process. So we're also going to be working with a JW Transmissions Ultra Bell. So given the amount of power this engine's putting out, we're talking between 600 and 650 horsepower as it sits right now, and that could certainly increase based on what the customer decides to do. We're going to be running a JW bell housing. Now, I mention this because initially the customer bought another bell housing, another JW bell housing on Facebook Marketplace, and it turned out it was for a power glide. I mean, the guy sold it as a Ford C4 unit, and they look very similar by eye, and if you don't build transmissions, it's not something you're likely to catch, so to speak. Well, anyway, I want to give a shout out to JW because once we realized we had the wrong bell, he contacted the company and they agreed to take the bell that he purchased off Facebook Marketplace back. All right, this bell was never installed, basically brand new. Somebody else had it for a project and never got, finished or whatever. And they are agreeing to take it back and exchange it. I mean, they'll probably have a restocking fee. I think he mentioned that there is a small restocking fee, but I mean, think about it. He didn't buy this bell housing from JW originally. He bought it from somebody on Marketplace, and they're still agreeing to work with him so that he doesn't get stuck for the roughly $1,000 that he paid for that other bell housing. So again, big shout out to them. Anyway, let's go ahead and get a little bit closer to the bench. We'll walk through part selection considerations for building a C4 for something like this, or something really high RPM, high horsepower. We'll get into all the details around the parts that are going to be different and everything we're going to be doing, and then we're going to begin the build-up. So let's get started. Okay, so we have all our bolts laid out in small parts. He's going to be running a different selector shaft or manual gear selector than what came from the factory. We're going to be running a full pattern reverse manual valve body. Alright, this was built by Dynamic Racing Transmissions using Broader Performance's engine braking and manual low kit. So this transmission is going to be 100% manual controlled, no automatic shift pattern whatsoever. So Dynamic Racing Transmissions dyno tests all of their valve bodies to make sure that they're fully functioning and working properly before they go out the door. So that's why you see it kind of laden with transmission fluid. Okay, they also provided a billet steel input shaft. So anytime you get up more than about maybe 450, 500 horsepower, it's a good idea to install a billet steel shaft. And ideally, you really want to pair that shaft with a billet forward drum. So, as you guys know, I regularly work with CK Performance on parts, and in this case, no different. CK provided this rollarized billet forward drum, so that's what we're going to be using in this build. Okay, we have a Sonex billet large ratio servo for intermediate, and then we also have a pump that was completely gone through, machined, and made 100% to spec and modified for performance by Dynamic Racing. So what they did is they went through the pump completely, and in this case, now this transmission I should say was featured in my back shop teardown video, so it's the same transmission. And when Matt took this pump apart, he found roughly a desert's worth of media blast or sand-like material inside that pump. So if you watch that video, you recall me saying that this thing lasted something like maybe 2 or 3 hours before it quit working on the customer, and that's when he pulled it out and brought it to me. And the reason for that was because whoever had built this transmission, they had either blasted the pump, or the pump was in close proximity to blasting cabinets or equipment, and it was laden, and I mean laden, with blast media. So you can't do that if you're working on transmissions. You can't have fabrication or media blasting or whatever near parts. Alright, so enough of that. We have a whole bunch of selectives on the bench. So this is going to be your number 2 thrust washer. We have multiple different versions. This sets your main end float in the case. So my recommendation is, if you're going to go back through these transmissions maybe for the first time, go to your local parts supplier and just see if they have like a miscellaneous parts bins for all the cores they've torn down, and maybe pick up 3 or 4 different thicknesses of number 2 washer. The number 1 washer is also selective. This goes on the pump stator, so you want to have different versions of this as well. And then ideally you want to have as many different thicknesses of forward clutch or direct clutch snap ring, these are basically the same snap ring, as you can find. Now I have 3 different versions. The 2 that are on the clutch packs themselves, these 2 here, and this one. This one's 67 thousandths, this one's 65 thousandths, and this one's like 62 thousandths. I think these are all variations of the exact same snap ring. I think there's 3 different thicknesses, but I'll flash a chart on the screen so that you know exactly what's available and what you need to acquire if you're out of spec when it comes to clutch clearance. Okay, we have additional steels. So we're running all choline steels in the forward and direct. These are factory spec thickness direct clutch steels, as well as factory spec thickness forward clutch steels. These actually came out of the transmission initially, and they're basically virgin. They've never been used. So I'm not exactly sure what transpired between when the customer initially ran the transmission and had all kind of problems with it. I think what took place was he took the transmission back to the company that built it previously, and what they did is they kind of went through it, put it all back together. I guess they didn't do anything with the pump because, like I said, it was all contaminated. But they cleaned everything else out because it hadn't been ran after they gave it back to the customer for the second time. So, all right, we have Teflon sealing rings here. It is my recommendation that any high performance, high RPM application, you do not run the factory cast steel rings. They will tend to dig into the inner diameters of the forward and direct drums, as well as the governor support housing or rear housing, and that will obviously cause blow-by, cross leaks, and ultimately doom the transmission to an early demise. Factory, daily drivers, occasional cruiser type vehicles, they're fine. The cast steel rings are fine for that, but you really don't want to run them in something like this. All right, we have our main overhaul kit over there. Okay, this is just a basic Trans-Tech kit, so it has all your paper and rubber, and then everything you need soft part wise, and consumables, gaskets, O-rings, machine cut square seals, etc., etc. Alright, and then for the servo, I purchased a Sonex servo kit. This is the seal kit for the C4 and the C5 billet servo. These seals are used, so I don't want to put used lip seals back in. So this is the part number. It is K13259C-SK. So if you have a billet servo and it's it comes in with the transmission, that's the kit you want to buy to R&R the seals and the gasket. All right, let's move a little bit further down the bench. We'll go over the forward and direct drum in detail, show you the components we're going to be installing there, the clutch packs, the direct drum, billet piston return spring assembly, and then we'll move into the gear train. Okay, so for the direct drum, we're going to install a power pack. This is a 6 clutch, 6 steel clutch pack that was developed jointly by Alto and Dynamic Racing. So we want to look for or target 0.010 of an inch per friction for clearance. So roughly, say 57, 58 thou on the low end to maybe 65, 66 thou on the high end. All right, now we have our billet piston and return spring assembly and the snap ring. So again, same deal, just like everything else high performance. You want to address areas of vulnerability in the transmission when it comes to the stock parts, and the stock piston can get a little squirrely and be susceptible to failure, basically breakup in really high power applications like this, because remember, the direct clutch is a working clutch, it's a shifting clutch, so it's shifting under both torsional stresses as well as straight line torque through the drum as throttle is increasing to wide open. So again, in a stock to mild performance application, the direct drum piston is fine, the one that comes from the factory, but in something like this, it's always best to upgrade to something billet, something much stronger. Okay, here's the direct drum itself. It's been fully prepped by Dynamic. Okay, you always want to check in here for sealing ring groove wear. Again, that's where the cast steel rings become a liability in higher RPM applications. So notice here we have a second snap ring groove machined toward the top of the drum, top of the lugs. So this was a 5 clutch drum initially. We now have made it a 6 clutch drum to be used with this power pack. Okay, front band or intermediate band is going to be a Kevlar band, again from Dynamic. So they build a transmission they refer to as their Mighty Mite. It's a C4. They have 2 different variations of it. There's the Mighty Mite 1 and the Mighty Mite 2. So we're basically building more or less a replication or a close approximation of their Mighty Mite 2. It features all of the rollerized and or billet parts that you see here, as well as valve body of the customer's choice. Alright, so for the forward drum and the forward clutch pack, we have 5 frictions, 5 steels, okay, and then we have direct clutch steels that we can swap in if the forward clutch clearance is too loose. Here you want to target somewhere between 25, 26 thou on the low end and maybe 35 thou on the high end. Okay, you always want to replace your Belleville plate. These will crack, especially under high performance, high RPM, so it's just good insurance to replace them on all your C4 and C6 type builds in the 727s and the equivalent 4 speeds as well. Alright, the factory piston for the forward clutch is not necessarily vulnerable here like the direct piston is, because the forward clutch is not a working clutch, it's not a shifting clutch. So once you're in a forward pattern range setting or range position, that clutch comes on and stays on, and it doesn't come off until you shift into neutral, reverse, or park. So it's not as vulnerable. Alright, so we'll take a closer look at the forward drum here. It's billet. So this is a 1973 unit. So in 1970 was kind of a unique year for these C4s. They had a 26 spline input shaft, meaning 26 on the converter side and 26 splines on the forward drum side. 71 and up, they went back to 26, 24, so 26 on the converter side and 24 on the drum side. 64 through 69, or 68, I think, 68 or 69. It is not my recommendation you use those cores for the basis of a high performance build, because they're 24-24 when it comes to the spline count on the input shaft. Alright, now this drum is rollerized. This is the factory thrust washer that normally goes here. This thrust washer is failure prone, and whoever built this transmission put this one back in. You can buy these new, they are available, but they didn't put a thrust washer kit in here, so it's stuff like that if you're a person who's not going to rebuild your transmission yourself, you really want to kind of dig deep a little bit into part selection when talking to shops, because you really want to know exactly what they're going to be doing to the unit. Are they going to be replacing bushings? Are they going to install a thrust washer kit, a bearing kit? What kind of sealing rings are they going to be using per the application? Things like that. And unfortunately, consumers don't really know, because, well, it's like they're not transmission experts. How would they know to ask these questions? Well, videos like this are helpful, books, manuals, doing a little bit of research can go a long way in helping you as a consumer understand what you need to focus on and what kind of questions you need to ask when interviewing shops and transmission builders for a prospective job. So anyway, that's just a kind of a tangent I went on there. You know, give a little, I guess, free chicken out to those that are not going to build their own transmissions. Ideally, you want to build your own transmission, though. All right, let's move further into the rear of the case. We'll start with the front part of the gear train. So this is a Dynamic Racing Transmissions fully rollerized front planet. When we say fully rollerized, we not only mean the thrust surfaces on the front and rear facing side of the planet here, okay? We also mean the pinions themselves. So there are little roller bearings, or Torrington bearings I should say, in each of these pinions. So steel planet. This is a great alternative to the 6-pinion non-fully rollerized planets that are out there on the aftermarket for these transmissions. And you know, in Speedway Dynamic, I mean, obviously they're gonna, you know, want to sell me their products, but Matt gave really good rationalization for why you would want to have a fully rollerized front planet, even if it has, you know, 3 less pinions, because it's really that rollerization combined with the steel housing and of course the, you know, overall quality of the planet that makes the difference when it comes to handling the amount of torque that's going to be pushed through this transmission. Alright, sun gear and shell. The sun gear is unremarkable. We put 2 new bushings, also a new bushing in the direct drum, new bushings and pump. It's the shell that's interesting. So we have a lightened, rem polished sun shell. Okay, this sun shell has been fully prepped and polished to allow for a little bit smoother flow and less drag, if you will, as it's spinning, and thus consequently less weight. Less weight means a little bit more horsepower passing through to the drive line and ultimately to the rear wheels. Okay, we also have a rem polished thrust plate. Alright, so this is the original washer that went on the front planet. So, you know, it would go right there. So again, this was not replaced. I mean, this washer is not in terrible condition, but a thrust washer kit would have a replacement washer. Alright, I'm going to move the camera down to the bench one more time so that we can cover the rest of the gear train. We'll talk a little bit about the JW Ultra Bell, and then I will show you some of the mods that we need to do to the case to, you know, kind of facilitate what we're trying to do here in this build. Alright, new low reverse piston, nothing remarkable there. Factory governor support, but no governor will be installed onto this support. So we have the 3 sealing rings, we have 3 Teflon sealing rings there in the kit, that's what's going to go here, but no governor, given we are doing a full manual transmission. Okay, stock output shaft. There are extreme duty output shafts available. The stock shaft's pretty resilient, so it shouldn't be something required for what we're doing here. I mean, obviously if he breaks it, then we know we found the weakest link, but in conversations with Dynamic and other folks, and from the research I've done on my own, this should be fine. Okay. One thing I have to do before we install it is just kind of clean up the journals a little bit with some fine grit sandpaper. Alright, front hub just has a new bushing. I mean, that's basically it. It should be fine. Otherwise, it is machined for the roller bearing, or the Torrington bearing here, so it's fully prepped and ready to go. Rear planet, no mods needed. We have the original thrust washers. These are actually in good shape. If there was one set of thrust washers I needed to be in good shape, it was those for the rear planet. Okay, we have the rear ring gear. The rear ring gear is going to be rollerized because we are working with a reverse drum that Dynamic provided to us with a Torrington bearing. Okay, so this has been machined and prepped. As you can see here. And then you have your bearing. Okay, this bushing here, I'm gonna be real honest with you. I've never replaced it, and I've not done many C4s, but Matt at Dynamic, I asked him about this. I said, you know, you're gonna install a new bushing there. He says, I have yet to see one that's out of spec. I have yet to see one that's bad. And he's built literally thousands of these over the years. So I've never replaced them. You can check them. You know, just kind of rock the drum onto the outer portion of the cam and see if there's a lot of play. You know, try to move them side to side, so to speak. And if there is, then yeah, this bushing will have to come out, but most of the time you won't have an issue reusing it. All right, Kevlar reverse band. I mean, it's factory dimension, just upgraded in terms of the friction material. And then we have our rear case support. So you won't always check these supports. This is not the original one. The original one was actually no good. It was undulated here. In other words, it had kind of a surface that felt waved, and you can clearly feel wear at the ceiling ring groove areas. So here you see the witness marks, but there's no wear. This is a good used one. Alright, so we are rollerizing the rear thrust. So this is going to be our inner race for our one-way clutch, and it's going to go on exactly as you see it here. And so the reason why you want this bearing set up like this is when this is installed, this outer portion is the portion that's actually going to rotate. The inner portion is not going to rotate. So when you put it in the case, this side will be facing, or resting upon the back end of the case. That doesn't rotate either. So you want to make sure you're matching your rotating halves with whatever's rotating in the case. All right, we're also going to rollerize the parking gear. So here we have an axial bearing. It's a 3-piece bearing assembly. So you have an inner race, the bearing itself, and then an outer race. So we just use thick assembly lube. That's how we'll put this on, and it goes on just like that. So here's the original thrust washer that came out of the rear of the case. Again, it's in decent shape. In a factory application, it's perfectly fine to reinstall or install a new one there. But something like this, it's going to be turning 6,000 RPMs. You want to rollerize as many surfaces as you possibly can. Okay, and then likewise, this is going to be the thrust washer for the parking gear, and same deal with that. This is a new low roller clutch kit. Unfortunately, the C4 does not have a unified one-piece roller clutch assembly like you can put into the C6s. I mean, they don't have one either from the factory, but you can retro the E40 D4100 low roller clutch assembly there, and you just omit the 2 snap rings. But the C4, I mean, this is it, So you have your cage, and then you have your rollers and your springs. And when we install these, I will show you exactly how you need to install them, talk through the orientation of the ends of the spring, because if you screw this up, then you will have failure at the low roller clutch. So we'll go over that. All right, low reverse band cover, snap ring for the output shaft and the governor support, bolts for the cover, and then of course our band hardware. Alright, I'm going to skip over the case real quick. I'll cover that last. So this is the pan that is going to be reinstalled. This came in with the transmission. It's a dynamic racing pan. I need to find another gasket for the drain plug because the one that came on there is like broken. And then this is the JW Ultra Bell. Let me get this a little closer. So this bell is designed to mate to the case via the pump to case bolts. So the bell housing to case bolts, bolt hole locations on the case will not be used. So everything mounts through the pump. Now I have the original pump to case bolts on the bench because when we go to put the case together initially, we are not going to install this giant bell because, basically it's just too cumbersome. I only want to install this bell once I have my overall end float dialed into where it needs to be, as well as my direct drum to pump clearance figure where it needs to be. And that is the number 1 and number 2 selective thrust washers job to regulate that spacing. Alright, and then this is just some paperwork that comes with the bell, instructions, little paraphernalia. Alright, extension house is not remarkable. It's a cast iron deal. Customer was looking for something maybe a little bit better, but I'm going to roll with that one for now. I wasn't able to find anything. Alright, I'm going to move the camera one more time and then we'll talk through the case. I will show you all the different mods that have to be done to convert a C4 to work for full manual control, and then we'll also show you a lube mod that I did to improve cooler flow back to the transmission. Alright, so not a whole lot of mods done to the case in general, but if you're wanting to convert your C4 to a full manual shift pattern or shift strategy, so you need to do two things. You need to use a 9/16 cup plug here at the modulator and delete the modulator valve. So as you can see, there's no valve in there. And then you're going to need to plug or block off the governor feed tube locations. So there is either a cup plug or a slug and then a check ball. I mean, you can do whatever you want. These methods work. It's just more or less not reversible. I mean, I guess you could drill through the check ball, drill through the plug, so maybe you can reverse it that way if you really needed to. Okay, new bushing in the case. Always install new bushing. And you always want to check your bushing to make sure that it will mesh and mate with your output shaft as it needs to. Okay, so it should slide in there nice and freely. Okay, if you're binding up, if it's got a high spot or something, you'll know it because when you spin it, it'll kind of bind up a little bit and you'll see where the high spot is, and then you can sand it down. Alright, so as far as polishing the journals, I like to use 400, 800, 1200, then 1500. Doing it that way, it'll make these mirrory smooth. So that's what I'm going to do with this before we install it. Alright, the one move mod you want to do with these is you want to drill out your return quarter line passage to 1/4 of an inch. Alright, let me see if I can get a flashlight actually to see that a little bit better. In fact, I'm going to reposition the camera and then I'll show it to you with the flashlight so it's, you know, obvious as to what you're seeing versus me trying to fumble around with it here without any light. Okay, hopefully you can see this, but essentially what you're going to do is take a 1/4 inch drill bit with a drill and just simply drill all the way through until you get to the other side, and that's basically it. So I've seen numbers of 3/16 of an inch, 1/8 of an inch, you know, as far as opening this up. Manit Dynamic recommended 1/4, so that's what we did. Alright, the last lube mod that you may want to do, it's up to you. It really depends on what you're doing in the back of the case. Concerns this little hole right here. This is going to be your feed for your low roller clutch assembly. So I've seen folks opening these up to 1/8 of an inch or so. And speaking with Matt, he advised that it's not actually necessary. He never opens it because they always rollerize the rear of the case. So if you're going to run a thrust washer, it may be worth modifying that hole right there, opening it up a little bit. But that's really it for the case. So let me kind of reset here. Alright, so that's a build overview. You have a full scope of everything we're going to be doing here. Should give you some ideas, you know, and sense direction, things to consider for building a C4 for an application like this. Something real high RPM, race, street strip, serious off-road type use. I mean, you know, we have a little bit of everything there with this particular build. So now let's talk order of operations. So first thing I want to do is set up the 2 drums and, you know, air check them and get the clearances dialed in, and then from there we'll go ahead and assemble the case. And we actually start at the back of the case and then work our way forwards in you know, one of these transmissions, and same with the C6. So the things that could potentially throw roadblocks in our way are clutch clearances and end float, and main end float meaning the whole case, as well as the space in between the direct drum and the pump. So that's again why you really want to have selectives on the bench of, you know, different thicknesses or dimensions, so that you can be prepared and, you know, just simply swap one for another as opposed to having to order something or, you know, run to the parts store. I'm going to take all the parts out of that overhaul kit, that paper and rubber kit you see there, and stage them to their, you know, respective locations within the case, and then we'll go ahead and begin the build. Alright, we'll go ahead and start with the direct drum. So we have our 2 machine cut square seals. They'll go on the drum and the outer diameter of the piston respectively. And then of course we have our clutch pack and the drum itself. So, you know, again, always check for a ring cut here and always put a new bushing. So lube up the inner diameter of the drum, just like anything else. Alright, and then go ahead and carefully install your machine cut seal. Alright, now go ahead and install your inner drum seal, and just, you got to be careful with it because these things will like to twist up on you. So just kind of work it down in a spiral pattern all the way into the, you know, down into the groove until you encounter the groove, and then the seal should fall in. Now, like I said, it's more than likely going to twist on you. So once it encounters the groove, you're going to have to manipulate it a little bit so that it can get into the groove, you know, the way it's supposed to. So this is twisted on me. So I'll show you. Alright, you see how twisted up that is? So you just have to take a few minutes to kind of manipulate it so that you get at least some portion of it started. And then once you do, you just simply work it around until you get the rest of it in the right way. So it can be a little tedious, you know, it's not necessarily difficult. The main thing is, obviously you don't want it going in all twisted up, that's all. Get that out of there. Looks like I'm gonna have to get a new brush for my assembly lube. That brush is something like, I want to say 3 or 4 years old. They actually last a long time, but this one's definitely starting to come apart. Alright, what I was feeling for down here is actually the feed hole. I wanted to make sure I didn't, you know, nick the seal. Alright, so here is the return spring assembly. So you have basically all loose springs, and they go into the piston. I'll have to count the springs off camera, and then I'll tell you how much they are once we go over to the press and install the you know, the return spring assembly into the drum. But I'm going to take them out for now so that we can install the piston. Alright, so here's a closer look at the piston. You know, it's got X number of springs. It's got a bleeder hole here, and it's made of billet aluminum. So smear a whole bunch of assembly lube onto this thing, and then smear more lube inside the drum. Get your screwdriver out of the way, and then carefully insert the piston into the drum. Rock it back and forth like you saw me do, just a little bit, and it'll go right in. Okay, if you use enough assembly lube, you won't have any problems. Alright, so let's go ahead and install the springs, and well, I guess we'll just count them. So we got 1, 2, 3, 4. Alright, so 25 springs. I gotta get this spring retainer fully engaged on all the springs. And we're snap rings, so let's go to the press and install the snap ring. Alright, fully compressed return spring assembly so that you have the snap ring groove exposed, and then go ahead and carefully install the snap ring. And of course I didn't open it up wide enough. There it goes. Okay. And carefully release tension. Alright, so if you're wondering what this tool is, it's going to be OTC 307-209. It's specifically for 6R80 overdrive clutch return spring assemblies, but you can use it in a variety of different transmissions. And then this tool is a Kent Moore tool. It is J24224-1, and I have absolutely no idea what it's actually used for. Did I say I have actually no idea what it's actually used for? Too many instances of the word actually. Alright, back to the bench. Alright, so here is our power pack. So, Alto Red Eagle. And you know, these are ribbed, or they're clearanced for lubrication passage, so to keep the clutch a little bit cooler than otherwise. Let's measure the thickness of the steel plates. So we have, looks like 58 thousandths thick on the steels. Clutch plates, 62 thousandths thick. And our backing plate, it is 128 thousandths thick. Yeah, 128 thousandths thick. All right, and then the snap ring that we're going to be starting with is 66 thousandths thick. So again, the target range we're shooting for is roughly 10 thousandths of an inch per friction. We got 6 frictions, so 58, 57, 58 is fine on the low end, and I would imagine 65, 66 is fine on the high end. If we're, you know, markedly outside those ranges, then we will need to make adjustments. And looks like we will definitely need to make adjustments. Interesting. So as you can see, it is slightly, you know, too much clutch pack for the factory snap ring, but we are nowhere near the other one. So that's kind of unfortunate, because ideally I did not want to go into the factory spec direct clutch pack steels, but that's, I think, what we're gonna have to do. So we have 4 of them, so let's see what we need to make this work. Let me clean that piston off. Alright, I'm gonna start with one of the power pack steels and put it on the bottom. So you're going to have less heat on the bottom, right up on top of the piston. The aluminum is going to ablate heat. It's going to, you know, shed heat more efficiently than anything else in here. All right, so now we'll put a clutch, and now I'm going to put a thick steel, a clutch, a thick steel, a clutch. No, that's not a clutch. Not a clutch. That's a clutch. That's a clutch. Thick steel clutch. And now I'm going to start putting, well, you know what? I'm going to put one more thick steel. I may need actually 2 more of these thick steels. Well, let's see. Got a thin steel. I got a clutch. And I got my snap ring. Backing plate and snap ring, excuse me. Excuse me. This thing wants to be ornery on me. Alright, we can do a hasty measurement real quick just to see if we're even remotely in the ballpark. Like I said, 60 thou is kind of what I was shooting for. So I got 59 thousandths here. Alright. And we are significantly higher than that. Maybe not actually. What it was is the only the 29 thousandths field of gauge was actually going under initially. Maybe not. We might be okay. We might be okay. However, I now have no choline seals in reserve for the forward clutch in the event we set that up and we need a thicker steel. So there's the gap. We'll see when we go to air check and actually measure it with a dial indicator, you know, if we're in the ballpark or not, once we do the actual clearance check. Alright, so we'll keep these aside. Got 4 of them. So 4 of them plus 4 of the forward steels, and they appear to be very similar in thickness. So we said these were like 58 thou, and the forward steels are 60 thou. So 2 thousandths is largely immaterial, at least on the individual level. At the clutch pack level, it could be material because 2 times 4 is 8 thousandths. That could make a difference. All right, let's move to the forward drum. Okay, one thing I want to point out first when it comes to the input shaft is the way the factory shaft splines into the drum compared to the billet shaft. Okay, so we have billet shaft on the left, factory shaft on the right, and so this is going to be our forward drum side, and then this side is the converter side. So first thing you'll notice is the length of the splines. Alright, the billet shaft has significantly longer splines than does the factory shaft, and that's true on both ends. However, when you install the factory shaft, you'll notice that it will penetrate all the way through. You know, in other words, the base of the shaft will travel past this portion of the drum. Conversely, the billet shaft does not do that. It's designed to stop here at the bevel. So what that does is ensures that it does not make contact with the output shaft. With that out of the way, we'll go ahead and assemble the drum. So you're going to have 2 seals, an O-ring seal for the drum itself, and then a perimeter seal that has a white stripe on it for the piston. like the direct drum, lube everything up inside, get everything nice and saturated, and then you can go ahead and install your O-ring. Alright, just carefully maneuver it over the journal and get it into the groove. And then just coat it with more assembly lube, and then do likewise for the inner diameter of the piston. Now you always want to check your bleeder balls and anything that has a bleeder ball capsule. If this bleeder ball is not functioning, then fluid will begin to pool up and behind the piston and actually push it forward, so that the clutch will either drag or actually come on out of schedule, resulting in a bind up or tie up. So you want to make sure that the bleed function is working, so that when you shift out of a forward range position, this releases immediately. Alright, again, the same deal. You want literally a ton of assembly lube. The other thing too is you do want to check the inner diameter of the forward piston, make sure it's not excessively worn, you know, where you're at risk of actually having a no sealing condition, you know, where it just literally doesn't seal, there's blow-by happening. That's no good, obviously. I mean, common sense stuff really, but something you want to make sure you check. Alright, this is the extra snap ring, or maybe it's actually here. So 65 and 67 thousandths. I'm actually going to start with the 67 thousandths. The forward clutch, unlike the direct clutch, you don't want a lot of clearance in here relative to the direct clutch. So high 20s, low 30s is what you're shooting for. So make sure you put your Belleville ring support or spacer in there, and then your Belleville plate, and then this is going to be the snap ring that goes into the lower groove to retain the Belleville plate. Now I'm going to clean this paint off, otherwise it's going to, you know, get in the transmission. But because I don't do these a lot, I mark this to differentiate it from the clutch snap ring. So let me clean this off and then we'll install it. And incidentally, I mean, this is probably something I should have mentioned first, but you see you have one end squared off and the other tapered. I mean, that's how you can differentiate it from the clutch snap ring, which both ends are tapered. I should have mentioned that first. I mean, that's kind of the obvious thing, of course, right? But, you know, I have my own way of doing things sometimes that doesn't always make the most sense. Alright, so you're going to have to work this around, you know, try to get it started under the groove, and then the best way to do this is take a hammer and a flat blade screwdriver and just gently tap it all the way around into the groove until it's fully seated. So I like to do this with the drum kind of against my belly. So at the risk of showing you my belly, that's how I'm going to do it. So kind of like this. And then just start wherever you have, whatever end went in first, that's where you start. Alright, so I swapped out that other Belleville plate with the original one that came in this unit, and I was beating on this thing like a rented mule, like a red-headed stepchild, to get this snap ring to go under the groove here. And as you can see, I screwed up my glove as well. I just started the snap ring on the original plate, and it seems like it's going in as it should. So I'm going to finish installing it, and then from there I'm going to stack up the clutch, you know, we'll measure our clutch clearance, go through the whole process, and then if I can't find a new one of these are aftermarket, they're not Ford, that will fit, then I'm just going to roll with this. And I know that's not good practice, but I don't know what else to do. So we'll go against the belly again. And I just adjusted the camera just to make sure it was in the shot. You know, everything was in the shot. Okay, minor amount of nicking on the drum itself. I mean, it's very frustrating when it comes to the aftermarket stuff. You know, with these old transmissions, there's certain parts that are obviously not in production anymore, and you have to deal with the aftermarket, you know, what the aftermarket has available, and a lot of times it just doesn't work. So it could be too that the groove here is ever so slightly undersized by some dimension. This is just me speculating. I'll have to check with Chris at CK to confirm or deny. But bottom line is that this went in and it took all of 2 minutes, whereas I was pounding and pounding and pounding on the other one, and it just wouldn't go in. So I measured them too with the dial calipers right on the edge. So I measured right here, you know, and then I took another measurement here, and they appeared to be the same, but it could be that maybe this angle's a little steeper, you know, the actual bevel itself, or there's another, you know, some other physical attribute or aspect that I'm just not seeing, and I'm not able to, you know, identify it when measuring, you know, each of these two plates. So very frustrating, and I know it's not what you want to see during a build. You want to make sure that everything goes nice and smooth and according to plan, but that's unfortunately not what happened here. So, okay, that actually appears pretty close. If not, I have a 62,000 snap ring. If we're tight here, like if we are less than prescribed 25 to 30 thousandths, then I'll just put that other snap ring in, or I'll stick a few of these, you know, a couple of these power pack discs in there, because they're 2 thousandths thinner. So again, 2 thousandths individually, not material. 2 thousandths in the aggregate is material, and it may help us here. Okay. So sometimes, you know, when you're building transmissions, you run into these kind of situations, and you know, you just have to improvise your way around. I mean, it's easy to get frustrated. I'm a little frustrated, obviously, as you can tell, but you can't fly completely off the handle, because then, you know, real bad things could happen. You start throwing parts, you know, banging stuff. Maybe you throw a hammer, or, you know, who knows, somebody walks in the shop and you beat them down, and you know, there's all kind of consequences to that as well. So you just want to do the best you can. If necessary, step away from it for a few, take a break, and then come back. Alright, so this is for our governor support, the 3 sealing rings there, and then we have 2 sets of sealing rings, 2 apiece for our pump stator. So let me go get a glove and then we'll proceed. I'll fire up the shop air, we'll work the clutch packs, and then we'll do a measurement for clearance for each. Okay, so for our stator we have 2 sets of sealing rings, and you'll notice the sealing ring grooves are not of the same dimension or thickness. So you have thinner sealing ring grooves here and thicker sealing ring grooves here. So these are going to be for your forward clutch, and then these are going to be for your direct clutch. So just like all these scarf cut style Teflon sealing rings, you want to make sure that you have the 2 ends mated correctly. This would be incorrect, this would be correct. So go ahead, pre-wind them. You know, nice little pre-wind like so. That will ensure they hug the groove there nice and tight. The main thing is you don't want these things getting caught and protruding when you're trying to install the pump. It may be a good idea to just leave the direct drum and the forward drum on the pump assembly for a while you work on other parts of the case. And that'll help them size to the inner diameter so that you don't have to worry about nothing. Now the one thing I'll mention here proactively has to do with air checking Teflon sealing rings versus the cast steel sealing rings that come in all these kits. So cast steel sealing rings will air check much more robustly in most cases than will the Teflon sealing rings, and that's because these Teflon sealing rings are designed to work in the presence of hot transmission fluid. So when you have the sealing ring and you install it, okay, what will happen is fluid will get in behind the sealing ring, and then it will immerse the sealing ring all around in fluid, envelop it, and heat combined with the presence of fluid will push the sealing ring outward, close this joint up tight completely, and that is how it will seal against the workpiece, in this case the forward and direct drums. So with that said, if you have a little bit of air leakage, you hear some hissing, don't be alarmed. That does not mean you screwed up the installation of the piston. It just simply means that you have normal blow-by on these dry sealing rings. So little green assembly lube. I may have to take that bottom sealing ring out and resize it, rewind it I should say. The top sealing rings are cooperating nicely. They're not causing me problems. Alright, so put the green assembly lube, at the end joints or whatever. And then you can test these one at a time, or you can test them in tandem. So what I'll do is I'm going to install both of them. Just want to be real careful. Make sure that they go in all the way, nice and easy. You don't want to get hung up anywhere. You don't want to break a sealing ring. Okay? And then, just check, make sure everything's good. And then from there, I'll let this sit there. Okay, you just want to let it sit there. There's a couple other things I have to do real quick. I got to make a phone call, and then we'll go ahead and resume. From your perspective, it'll be instantaneous. It'll just be the next frame. For me, it'll probably be about a half hour, and that will allow these sealing rings to size nicely. Okay, so what you want to do is you want to kind of work the clutch packs, but one thing I didn't do, actually two things. I could already tell that this is too tight for forward, so I have a relatively thinner snap ring in the direct clutch, and then this is the thickest snap ring I have. So I know I switched them out, or at least I'm almost positive I switched them out during either the intro or somewhere in between the intro when I started the actual build. So if I did, then that's kind of a textbook case of overcomplicating things, because the thicker snap ring was on the direct drum and the thinner snap ring was on the forward drum when I originally tore this thing apart. So let's go ahead and just swap them real quick, because the direct drum may have a little too much clearance. So this way we can even things out and get where we want to be for both of these clutch packs. Alright, and then the other thing I didn't do was put a thrust washer. Get that in there. Whichever way it'll go on. Alright. Put the clutch pack back in. And if I'm still too tight, I have the power pack steels, so I can swap in a few of those to loosen it up a little bit if that becomes necessary. So it's always good to have a lot of different selectives so you can mix and match and get where you need to be. I still may need to do that. This to me looks like it's about anywhere from like 16 to 20 thousandths. Alright, let's go ahead and put the indicator, and what I like to do is measure here, here, and here. And you can measure at the snap ring groove, but to be honest, it's always going to be greater than anywhere else. And so I've been taken to just using 3 measurements like so, and averaging the 3 to get my mean clearance. Alright, so let's see where we are at. So this is your forward feed, this is your direct feed. Let me see if I can get the camera to zoom in on the gauge. Alright, so like I said, somewhere mid-20s to mid-30s for the forward clutch. So 24 thousandths, 25 thousandths, 26 thousandths, because we're returning to 1 below 0. So that's 26. And this is typically going to be the tightest spot along the clutch pack, 180 degrees out from the opening of the snap ring. Alright, let's give it a go. Alright, so this is telling us 38 thousandths. So, fair amount of variability here. 30 thou. It's returning to 1 above 0 and it's going to 32, so I'm going to pull that 31. Alright. Handy dandy calculator. $31 thousandths clearance, that should be fine. I'll have to check the manual to see what it says, but from what I recall, like I said, somewhere in that mid-20s to mid-30s range is acceptable. So you could check the forward drum by itself right here. You know, if you want to verify that you have installed that piston correctly, and you just go like this. And obviously your apply, your robai. Trying to combine words now. Your apply is much more robust. So like I said, you will always have sealing ring air blow by with Teflon sealing rings. It's perfectly fine. Nothing to worry about. You didn't screw up. You didn't nick the seal on the piston. The other thing you can do to just double, triple, quadruple verify is when you're putting air into the clutch, charging it, you can try to move the clutch, So like for example, see how I can move everything? I can move frictions around to work it. You can do that while you're charging it and you have let's just say at least 50 psi air, then something's wrong. Okay, I can't move that, and my air nozzle wasn't fully sealed over that little port, but you get the idea. So I think the forward clutch is done. Alright, now the direct clutch. So 10 thou per friction for something like this. In a stock application, I think you run the clutch clearance down to like maybe in the mid 40s. But for high RPM, you need a little more breathing room. I mean, the clutch is still going to apply, you know. You don't want too much though, because if you have too much, then it'll bang shift, or even, you know, if it's in extreme cases, it'll flare shift. Because remember, this clutch is part of a timing event, an exchange between the intermediate band and the direct clutch to give you a smooth transition from second to third gear. So too much clearance in this thing, then it might flare. Not enough clearance in it, it might tie up. And again, we have high rate return springs to further mitigate any kind of centrifugal apply, drag, or whatever at high RPM. So we're at 0. Let's see what this gives us. Not quite at 0. There we are. Alright, 90 thou. So that's obviously no good. It's like 88 thousandths. $86,000. So I'm not even going to write anything on there. We know that's no good. So I'm going to be in search of some more components to get this thing where it needs to be. So let me see what I can find. In fact, let me take this clutch out real quick. I think I have power pack frictions, or excuse me, power pack steels in here. I'm going to dig up some other steels that are, yeah, we have power pack steels. Okay, no big deal. No big deal until I actually try to remove them. Then it's a big deal because they don't want to come out. Alright, so we have this one power pack steel on the bottom, and then we have the one on the top. So both of these are going to have to come out. And I think this is stuck on assembly lube. Yeah, let me get a pick. Come on now. Alright, so we have the following thicknesses. This is 57 thou, 58 thou, somewhere in that neighborhood. Or maybe 59 thou. I mean, that's kind of what we're looking at. So none of these steels were able to be used. And I know these are forward steels. And these are 60 thou, so basically it's the same steel for all intents and purposes. For what we have going on right here, so I need 2 more of these thicker steels. So let me see what I can find. If not, I gotta run to the parts store, which is like a worst case scenario because I wanted to get this thing done today, but you know, sometimes this happens. Like I said, I did not think I was going to use all 4 of those direct clutch steels, but that's kind of what happened. Alright, I'll be back. Okay, so got 2 more factory spec cooling steels. So we'll go ahead and stack this thing back up and see what kind of clearance we have. So we're at roughly 90 thousandths of an inch, and we want to be at roughly 60 thousandths of an inch. So 6 and 6. And if this works out, it'll be for the better, because now I'm able to use factory spec thickness in terms of the steel plates versus the thinner power pack plates. And I always like to be thicker whenever I can, and at the same time, you know, plus up the drums. So this will actually work out perfectly for the customer and for the build if I can get this this clearance to where I want it. Alright, let's see what we got. Stick the snap ring back in. And if I'm a little tight, I can just swap in one of those forward steels or a power pack steel. Because one thing to know is there's not always a linear relationship between you know, the thickness of whatever component, selective or part, and the measurement itself. This should be here. So sometimes you'll do the math and then you'll swap in components that would, in theory, yield a perfect result in terms of the delta between, you know, the measurement previously and the measurement now. But sometimes that's not how it works. Alright, let's make sure you can see the dial indicator. Start at 0. And let's see what we have. Alright, so we're 45 thou. So that worked out to be a little bit too thick, which is fine, because now all I'm going to do is take out one of those one of those thicker steels and stick a thinner steel in there. Got dots on both sides. I don't need dots on both sides. So the little bit thinner steel. So forward clutch steels are 60 thousandths. I think the book spec lists them at like 61 or 62, but these are 60 thousandths. You know, these particular steels that I have over there. So let's see what we have now. Alright, try it again, direct clutch. Alright, 65 thousandths. So, let's see what thickness of snap ring I have in here. This is also 65 thousandths coincidentally. Uh, 66, 67. I don't think it'll make a difference, but let's see. This snap ring here is the thickest snap ring that I actually have available. And 63 and a half, 64. I'm going to call that 64. Now 65, 66, let's call it 66. 65. I really need a snap ring that's like 10,000ths of an inch thicker, and I don't have one. The parts store does not have one. And this is probably going to be like 70. Oh, I'm wrong. 65. So 65 all the way around. This should be fine. I don't see why or where it would be a problem. The 65,000ths thick snap ring is going to be the most common that you'll encounter with the direct clutch. Like I said, I flash a chart on the screen during the relevant junctures of the video so that you can see what exactly is available. But that one was 65 and this one is actually 65, so I guess I mismeasured it initially. So absent somebody, you know, like the snap ring fairy bringing me, you know, 10,000ths thicker snap ring, this is going to have to work. I don't have any other kind of intermediate thickness steels between, or I guess like an oversized steel. An oversized steel would work. I asked the parts supply shop about, you know, one of those, and they do not have them, and I would not be able to get them until next week. And this needs to go out the door this week. So I did consult with Matt Dynamic, gave him a range of where I figured I'd likely be between 55, 65,000ths, and he said that you know, plus or minus 5 should be fine. So that's what we're gonna work with. Okay, I'll put the drum over there for now. Grab the forward drum. And we're just gonna stick this bearing in here. In fact, I gotta lubricate it. So you can lubricate your bearings in either Dex 3 or Dex Merc or Type F. Any one of those solutions is fine. I don't know of any other fluid that you could use in these things, but I don't know that I would use Mercon LV or Dex 6 or anything like that. I mean, I guess you could, but I've heard mixed things about using the more modern formulations in some of these older units. Some folks have ran Dex 6, for example, 700R4s, and you know, they didn't have any issues, but then other folks have told me that they in fact did have weird shifting anomalies when they would use the full synthetic stuff in the older transmissions. Custom Ready TH400, he tried to run Dex 6 in it, said it shifted kind of odd, flushed it, put regular Dex Merc in it, and the shifting issues went away. And that story is, you know, I would say repeats itself a handful of times over the years with my customers and some of the older transmissions. But for these, you can use either Dex Merc or Type F. Type F will give you a little bit firmer shift. The friction modifiers used in Type F are a little different, and I want to say that some of the performance transmission fluid that's available for GM and Ford transmissions uses a Type F friction modifier as the basis for that formula, and then they add their own proprietary stuff, of course, but you know, it's all certified to meet the standards for either Dex or Type F or whatever, you know, fluid they're manufacturing it for. So I decided to go to the parts store to see if I can find an oversized steel that's roughly 10,000ths thicker than factory. And you know, I know that they told me they didn't have any in stock, but when I went there, I asked them to take a peek on the shelf, and it turns out they actually had one. So this steel is going to be 95 thousandths thick. So what I'm going to do is I'm going to install it here into the direct clutch and see if that makes a difference and see where we are at. Because while 65 thousandths is okay, I would really prefer to be on the near side of 60 instead of the far side. So meaning I'd want to be 60 thousandths or less. Alright, so we already have one forward steel in here. And then now here is a factory spec steel, and this should be like 78 thousandths, give or take. Alright, so what I'm going to do is I'm just going to swap this right into the middle of the pack, and then we'll go ahead and put the forward steel back in, and then our backing plate. So 55 to 60 is really what I'm after. I have to move the camera back once I get the dial indicator set up, because otherwise you're never going to see it. Alright, we're at 0. Let's go ahead and put some air. Alright, 55 thousandths. Alright, rotate. $52 thousandths. $50 thousandths. It's like 52 thousandths there as well, was returning to 1 above 0. Alright, so let's see where we're at. Probably at 53 thou. Divide that by 4. It's 52.55, so 53 thousandths. I actually like this a little better because clutch clearances, in my experience, tend to open up, you know, once the transmission starts working relative to what you measure on the bench, and they open up about 2 to 3 thousandths, sometimes more. Like for all 60Es, I've seen them open up as much as 5 or 6 thousandths. In some ones that I have measured, and the transmission will come back to me either in the rare cases because there was some sort of mistake, or in other cases for refresh. So these are high performance units that, you know, periodically do come out, and I always record my clearances in the build sheet for each customer, and that gives me the reference I need to look back and compare if a unit comes back, because I always measure the clearances, you know, in a working unit versus a unit that's dry on the bench like this. Okay, so we're now done with the direct clutch. I am much happier with this result than I was with the 65 or 66 valves, because again, following my same train of thought, that probably would have ended up close to 70 once this thing starts working. So just tidy up the bench a little bit. I know I could have easily edited out all of the, mixing and matching and multiple iterations of direct clutch stack up, but I wanted to leave it in because that's forward clutch. I wanted to leave it in because this is typical of some of the obstacles or challenges you might encounter when building transmissions in general, and from my own personal experience, limited as it may be, with C4 transmissions in particular. They are somewhat sensitive to clutch clearance. You can't just, throw it together, with way too much or way too little and think it's going to be fine. And that's really true of all transmissions. But I've just found that the C4s can be tricky because you never know what you're working with, especially for performance applications, either using aftermarket parts or, parts mixed and matched with factory components. And where you're trying to get everything to stack up correctly and give you the clearance you need, it could get a little tricky. Compounding this, increasing the risk that you might have problems is the fact that these snap rings for different thicknesses other than this 65 thousandths thick version are not readily available. My part supplier can't get them. I've called Transparts Warehouse, they're often out of stock of them. I mean, they're not in production anymore, so, there's not much that the suppliers or the retailers can do. If they, supply isn't there, then, well, it ain't there. And that's what you're wrestling with. So I'm going to just throw the sun shell together real quick. And so these shells are pretty neat. Like I said, they're markedly lighter than the factory equivalents, and this rem polishing is pretty slick. I mean, look at this thing. Pretty cool. All right. Actually, I put this back up there. I actually need it. So new bushings in the sun gear. So we just lube them up. When you're installing bushings, you want to make sure that you're not accidentally blocking off lube passages in the gear itself. So sometimes it's a good idea to just shine a flashlight and make sure that for whatever you see on the outside in terms of lube hole, that you can see light shining through from the inside. If you can't, then you got to move the bushing. Centered. So this, when I took this off, this is actually the front. This was facing the front. So you want to put that down in there like that. And then you can go ahead and you could drop your thrust plate. Now I don't know if this makes a difference or not, but typically the side without the witness mark is the side that faces the sun shell. And, well, the other side faces, you. These little snap rings can be tricky as well. You just got to be, kind of quick with them. Otherwise, they'll want to get hung up. Okay. So we have our planet. This is the front planet. We got to dunk this in transmission fluid, and then we'll go ahead and install that. And then this is our ring gear, so let's lube up the bushing. And then forward drum and direct drum normally would follow, but what we're going to be doing is installing the assembly sans the direct run. And the reason for that is it's easier to measure your end float using the number 2 washer. So again, the number 2 washer goes on the back of the stator, and that's what is used to regulate end float in these units. And then your plastic washer, this one that goes onto the pump, simply regulates the space between it and the direct drum. Alright, let me dunk this in fluid, and same with this, and then I'll be right back.